Here we have to identify the domain and the range of these quadratic functions. If you remember, domain is all the possible x values for your graph. So domain are your x's, range will be all the possible y values. So domain is the input, what do you put into the function, range is the output. But we tend to remember it with x's and y's. So if you think about the x values for this graph, I go over to 2 on the x-axis and I can see I'm on the parabola right here. Here's where x is a 2. Well, this graph is going to continue. Here x is a 3, x is a 4, and it's going to continue forever and ever in this direction. Eventually it's going to hit every single x value in the positive direction. If I head the other way, here x is a 1, x is 0. It's going to keep going it's going to hit the -1, the -2, the -3. So this graph will hit every single x value because it continues forever in those directions. So our domain, which has to do with our x's, because it hits every single x value, will be all real numbers. And here's that symbol for all real numbers. Every single quadratic function will have a domain of all real numbers. So now it's the range that's going to be a little bit different depending on your function. Range has to do with your y values. Well, if you look at our graph, remember y values are these values going up and down. If I go to where the vertex is right here, see how the entire graph is above that vertex? You don't have any y values down here where your graph is. You'll have nothing down in this area. So when we identify our range, well, what is our range? Again, that vertex, let's see, it's 2. It's that y value, that -2. We have a graph at -2. The graph hits a -1 for the y, a 0, a 1, a 2. It's going to hit all those positives. Over on this side, the graph will hit a -1, a 0, a 1, a 2, a 3, a 4, but your graph will never be down here. So we say that our range, that all the y's are, in this case, greater than or equal to that -2. There's that -2 that helps us out with the range. Alright, this next example over here, domain and range, again, because the graph will hit every single x value, your domain will be all real numbers. And then it's the range that will be different depending on the graph. So we want to look at what's happening with the y's. Well, we get way up here with the y's. We get all the way up to a 6, and then the entire graph is less than the 6. See how everything goes down here? We don't have any graph up here above the 6. So what we say is that all of the y's, in this case, are less than or equal to that 6. Again, you can look at it with your vertex. That vertex is -2, 6, and there's that 6 that comes into play in our range down here.